Today you'll learn about variance and standard deviation and how using these two concepts helps us better analyze a set of data. We talk about an average of a set of data, and that's helpful in summarizing a set of data, but an average itself doesn't necessarily tell us the spread of the data, and that's what we're going to really focus on, the spread of the data or the variation of the data. And a clear example here in example 1, if we have two factories producing batteries, factory A and factory B, and from each factory 4 batteries are drawn to test for the lifetime. So in factory A, you could see the 4 different batteries didn't vary in terms of the length of time they stayed working, from 9.9 hours to 10.1 hours. And so the spread of the data here wasn't very high. So you could be pretty satisfied that the batteries from factory A would last relatively about 10 hours. And so in factory B, the smallest number of hours that one battery lasted was 5, and the largest number of hours was 16. So there's a huge spread in the data. So the mean lifetimes of both factories were 10 hours. But looking at the data, it's obvious, like I said, the spread of the data is greater in factory B. So in factory A, calculating the range for factory A and B, the range would be the highest number minus the lowest number. And 10.1 minus 9.9 is 0.2. And then factory B, the 16 minus 5 gives us 11. So the range for factory B batteries was 11 hours. So that's a huge number and a huge difference between the two. And if you were going to be purchasing batteries from one factory or another, you would certainly choose factory A because consistently they would last about the same. So that's the first part. The variance and standard deviation, we're going to look at the notation, and we're going to use our calculator to calculate these, and then we're going to do it by hand as well. But the variance, when we see this number on the calculator, that's the little sigma, sigma squared, and the standard deviation, this is the lowercase sigma, which is just sigma. And so those are the notations that we use for variance and standard deviation. So go ahead and turn your page and get your calculator out. Pause the video while everybody does that. And go ahead and clear your calculator. Clear the data that might be already in one of the lists. So hit Stat, Edit, and then highlight the name of the list, hit Clear, and hit Enter. And do that with any list that contains any values. But for right now, we're going to calculate the variance and standard deviation. Now don't worry if you don't understand those terms yet. We're going to calculate them, and then we're going to analyze what they mean, and it'll be easier to analyze and understand what they mean when you see how they relate to the data that we were given. So in factory A, we're going to calculate the variance and standard deviation by using our calculator. So we're going to input the numbers, 10.1, 9.9, and we're going to input those each twice. And then once we have entered the data, then calculate the mean. So calculate the mean, a little typo there. Calculate the mean, press stat calc, one variable statistics, enter, and then we have the numbers that we want. So the number that we want is the standard deviation. That's what we get right there. So it says the standard deviation is equal to 0.1. So standard deviation equals 0.1. Now if we take 0.1 and we square it, we know that that's and let's label that as well here. We've got standard deviation, you don't have to write the words standard deviation because we should know that that symbol right there means standard deviation. So standard deviation is 0.1, and then the variance is the standard deviation squared, and 0.1 squared is 0.01. So that's using our calculator to find the standard deviation and the variance. Normally we really are interested mainly in the standard deviation because it tells us, and we use the variance to get that. So it tells us exactly how far away from the mean, and that's what we'll talk about, how far away from the mean most of the data lies. And so most of the data lies pretty close to the mean when the standard deviation is low. Standard deviation is high. It means that the data spreads out and is, again, more spread out. So we're going to finish this example in the next video.